So, as you remember, so we talked about naive Bayes classifier, which is a kind of classifier, and like any other classifier. But the naive Bayes classifier is based on the Bayes theorem. So this is the Bayes theorem, you know that. But perhaps we want to understand it a little bit better. So what are the components of this formula which make the Bayes theorem, and based on that, then we will have the classifier. The components are made of two probabilities, simple probabilities, and two conditional probabilities. In order to memorize it, one can say, okay, we had an A here, a B here, so here we have a B and an A. But what does this mean? When you talk about the conditional probability in the context of classification, the given part, that means, so you say A given B, there's A is a class, B is a subset. Now we had this example that you have a class of girls and boys. So what is in common among these people? They are students. What is different are girls and boys. So you have girl student, boy student, girl student, boy student, boy student. So when you talk about a conditional probability, it means probability of being computer science student given the fact that the student is a girl. We don't want to write that S, because when you see this conditional probability, you know that we are talking about a subset. We are talking about a subset. So we can divide it like this. Girls are here, boys are here. Then you go in this subset and you count how many of the girls are computer science students. But we should not forget that we have been in this set, in the bigger set. You cannot simply count the computer science students who are girls, divide them with the number of girls. No. No, because we have the probability that, because now we have divided them like this, but being a girl itself is not certain. So, you know, if you take a student, being a girl, is not everyone is a girl. Yeah? So that itself is under question. That means that being a girl has itself a probability. Yeah, itself has a probability. So when we talk about conditional probability, like we have it here, we are talking also about the probability of the subset itself. So let's talk. I'm teaching you backward. Let's talk about now the components of the conditional probability. We say that this is our subset, this is our class. The probability of the class in that subset is the probability of what we said, being a girl and being a computer science student, divided by the probability of being a girl in general. So given the fact that a person is a girl, also should be considered. So this is the probability of being a computer science student, and the probability of being a girl is divided by the probability of being a girl. So this is from where the conditional probability comes. So up to now, we know what is the conditional probability. This by definition. Now, We said, so this is our class, this is our subset. How do we calculate it? In order to know the probability of the class inside the subset, you should know the probability of the subset in the class. It means that you tell me that given the fact that the person has studied or studying computer science, what is the probability of being a girl? It means that tell me how likely is that a girl is studying computer science. Yes, so that is called likelihood. This here is called the likelihood. How likely it is that a girl studies computer science. Then you have the prior probability. Prior probability. This prior probability is the probability of the class itself. How probable is that someone in general studies computer science? And then you divide it with the probability of evidence. Evidence. We know that the student is a girl. So we said all these things to define our conditional probability in the term of another conditional probability. Why is this, how is this useful? Again, I say that this is the class. This is a class. When I'm talking about a subset, I'm just saying that how are we going to define a subset? I said one could say that a girl who is a student can be categorized or shown like this. So we want to say someone is a computer science student given the fact that the person is a girl and is a student. So these are the characteristics. These are the characteristics of our subset. These are the characteristics of our subset. This is very important. This is very important to understand this condition as the characteristics of our subset. So here, the B is the characteristics of our subset. A is our class. Characteristics, class. Let's go a little bit further. I write this formula again here, but I used other characters. I say class given, so I'm talking about this formula. I have a class and a set of characteristics. I would call them X. So in our example was a girl, and the girl who was a student, so it was G and S, is equivalent to the probability of the characteristics of our subset given the class to the probability of the class itself divided to the probability of the characteristics of our class. So this way, having the characteristics of our class, our subset, we can say how probable is our class. Yes, so these are the characteristics of our subset. That in our case was a girl who is a student, and here we had the computer science. So this is the way we calculate this. But in the official definition, when you look, so what do you see? What do you see in the official definition? You see the probability of the class. You see the probability of the characteristics of the subset in the class. But you don't see the denominator because it's constant. Why do I say it is constant? It is constant because we are going to compare the probabilities of different classes given the characteristics of our subset to see which of them is more probable. So denominator is redundant there. You can put any number here, any number can be here, and it doesn't matter as long as this number is is in denominator of all our classes. So we don't need this here, and we have these components. So this would be here the probability of being a girl to the probability probability of being a computer science student, probability of computer science student, probability of being a girl, given the fact that you are a computer science student, to the fact that, let's say, you are a student and you're studying computer science. So you go, this probability actually is redundant. Or you can add other things. You can add other things. So if you are, I don't know, young and you're studying computer science and so on. So you may have many characteristics here, but the condition here is our class. The condition here is our class. So in order to find out theoretically, in order to find out the class of an object, you would simply multiply these to each other for each class. So argmax, I said argmax is a search, the argument which makes what comes after max. Yes. The argument which makes this maximum. Yeah. The argument which makes this maximum is the answer. So what is that argument? Is our class. Yeah, it is our class. We are looking for the class. We are looking for the class which makes this multiplication maximum. Yeah, we are looking for the class which makes this multiplication maximum, and that is the class of our object. It is very important. This is how the certainty and uncertainty are different. How being probabilistic or stochastic probabilistic is different from being logical. Here we don't say that we are certainly sure that what we are talking about. So the person that we said we saw a person and we are sure that this person is 100% a computer science student. We say, no, if you see a person coming out of this class and the person is a girl, with the probability of 80% she is a computer science student, with the probability of 20% she is, I don't know, mechanical engineering student. So then you announce the highest probability as the class. Yeah. So say for example, you look at the person, say which characteristic would match him or her the most. You think, could he be a student? Could he be a taxi driver? Could he be a medical doctor? So you are going over classes to see which of them is more probable. You guess. Yeah, this is the idea here. Yeah. What is, yeah. Yes, that is why we call it naive. Yeah, I will. That's a good point.
Yeah, but we know if the features are independent or not.
We don't know. That's why politely we say it is a naive way. It's a naive classification, but there are more complex classifiers which do not have that assumptions that the features are independent from each other. Yeah, very good point. Very good point. So this argmax, that was a very good point. Now we'll explain that more. This argmax is telling us which class would maximize this. Yes, he said a very interesting point. He mentioned a very interesting point, that how do you know that is our independent from each other. From where does this question come? From where does this question come? We said that we are contradicting ourselves. We said that the joint probability, the probability of two events happening at the same time, it means that, for example, the probability of being a student and a girl and being, I don't know, young, being, I don't know, jobless, being this and that, the probability of these things happening at the same time is defined like this. So you take the probability, the conditional probability between them. So you say, you can also write it vice versa. So P given A is equal to P B given A to P8. It doesn't matter, but we always have this conditional probability. It means that you should consider the probability of one of them happening inside the other one. Yeah? But in case of independence, so if A and B are independent, then P of A given B is equal to what? P of A. It doesn't depend on A. So in the case of the independence, P of A, the joint probability of P and sorry, A and B is simply the multiplication of their probabilities. Yes? That is why also here we have these assumption, we have this assumption that the joint probability of these things is simply the multiplications of them. I said multiplication. Multiplication causes a problem. What could be the problem of a multiplication here? What could be the problem of multiplication here? These are probabilities, yes? Probabilities are less than 1. If I multiply 0.1 to 0.1, I will get 0.01. If another comes, then it will be yet smaller. And because we are using computers, practically, these values can vanish away. So, this can vanish away. So as a solution, we consider the fact that logarithm of A multiplied to B is equal to logarithm of A plus logarithm of B. Good handwriting I have. So consider the fact that logarithm of A multiplied to B is equal to logarithm of A plus logarithm of B. No, in the exam mostly it will be about interpretation and application. So formulas will be provided. Yeah. Then we have the different kinds of. So in order to calculate these probabilities of our characteristics inside our classes. It means the probability of let's being girl in the class of computer science. There are different ways to calculate that. If the data is a continuous signal, you use this formula. If it is text-based, you use this formula. And if it is the binary, use this formula. Yes, that is this. We have a Python implementation. This is a short Python implementation that practically could be used, but I will show you a Python implementation which is a bit more detailed, to match what we have had in our formula. Yeah, to match what we have had in our formula, in our definition of the formulas. Okay, I'm trying to record this. If it is good, I will share it with you so that you can go back and forth, because some of the students, because also we have just 1 hour 20 minutes. If it is good, I will share it with you. The quality is good. Okay, let's go to the code. Naturally, we are using Python code. We should import some things. The only thing that you may not have seen before is regular expressions for string processing, which is nothing fancy. You will see it. So what do we want to do? We have a set of emails. We have a set of emails. Each of these is an email. Each of these is an email. Means we have short emails, but just 5 pieces of text, and they are labeled. They are labeled. The labels are in another list. So these labels correspond to these emails. 1 means spam, 0 means not spam. 1 means spam, 0 means not spam. You follow for example, you look the second email, buy money online cheap, has the label 1. It is spam, yes? And hello, how are you? Is it spam or not spam? It's not spam. So we want to have some statistical information about these things. Means we need numbers to act. So what is the action actually we want to do? We want our classifier to learn based on this label data. So we are supervising it. We are to learn to recognize a new text as spam or not spam. So we need to turn that text, those texts to tokens. What are tokens? Tokens are words in simple language. So we have this function which uses regular expressions. Yes, we turn off the light. Better. So we have this function which receives a text and returns a list in which we have our tokens or words. We will see how it works. So let's. So we said that if we have textual data, so this is a text. So we would use this formula. What is this formula? It says that the probability of a characteristic inside a class, now we will see what are those characteristics, is calculated by the count of occurrence of that characteristic within the class. We will talk about this later. And divided by the count of all words in that class. So what does that mean? It means that we want to see, so here the characteristics of an event are actually the words which are in the sentence. The event is a sentence. The characteristics are the words which are making that. So for example, so how many times this characteristics has happened in the class spam? The word free, if I click on it, you see it 2 times. So in the class spam, we have this word 2 times. How many words do we have in total in the class spam? I think we should have around 17, 16. So each of them has 5, 6 words. So the sentences which belong to the class spam have, I don't know, X many number of words, and the word free has happened in that class 2 times. The word money has happened 1 time. Prize has happened 1 time. So here it's clear what we have to calculate. Alpha is there to prevent having a 0 in here, to prevent having the probability 0. And V is a coefficient to make the denominator bigger than the numerator. These have names, but yeah, we will see them later, but it doesn't matter. W is the count of all words. Is a word, simply a word. W is a word.
That's C.
No, C is the class.
C, the words in the class.
C, no, C is the class itself. That is just a function.
Oh.
Yeah, C is just a class. Is 0 or 1. You mean in the here?
No, when we were counting in the codes, we were counting, like for example, free, the word free, how many times it appeared?
Yes.
Over the total amount of words in the class.
In a specific class, yes.
So that would be X.
Yes.
Okay.
Yes. But actually count of X over sum of the counts of the words in that. So we have a little W here. It means that keep the class constant, iterate over all words, and count them if they belong to that class. So we know what this formula is, and then let's see how it is implemented. So I have this loop here. It loops over all emails and their labels. Take them as couples. So one by one, first email with the together with the first label, second email and the second label together, turns the emails to the list of words, and based on the label. So now we are counting how many emails we have, how many of each class we have. So if you put the label can be 0 or 1. So if you have a 0 here, it means that in the dictionary of class count, this will be increased. If we have a 1, then this will be increased. This way, after we have gone over all labels, actually, we know how many of them have been belong to the class 1, how many of them belong to the class 0. And we need a vocabulary, is a set which doesn't have order and count. We just know, we want to know what are our words. What is this? Here we are having a 2-dimensional data structure. First dimension is the label. That means we have actually here it can be just 0 and 1. The first dimension. The second dimension is our word. So now I will show you after. Let me run all of them. Let's see what is inside the word count. So word count has 2 parts. One of them belongs to class 0, one of them to class 1. And in each class, it says how many times each word from the vocabulary is repeated. We have just the word free, which is repeated 2 times, and in the class 1. Do we have it in class 0? No. In class 0, we don't have it. So this is the job of this loop. Now let's see where this information is used. Okay, the famous formula, Bayes theorem. We want to calculate the A given B. A was our class given B. So first we need these elements here. Total samples, we just count how many emails we have. Then the probability of class spam, the probability of class not spam. So you count how many, so you have counted how many of your emails are spam, how many of them are not spam, and you just divide this count by the total number of emails. Then you will have prior probabilities. This means the probability of each class, the probability of each class. Then we can calculate this one. Why do we need this one? We need it for here. We need it for here. Or actually for this formula after applying log to find out the probability of each class. This is for the class 0, this is for class 1. So we look at this formula and find out where is what. The alpha here, we can see it. This is the denominator is a function of the number of our total words. And what are the rest? This you can see, this is the count of each word from the vocabulary in class 0. So we have class 0, we have class 0 here, the count of the word in that class 0. So you go one by one over all of your vocabulary or of your words and see the count of each of them. Then you will have this probability, the probabilities of each word or each characteristic of a sentence in each class. Then after that, you can do prediction. Prediction means calculating the probability. So what does it mean? What do we have here? This is the way that you probability of one class, What is happening here at the end is the argmax. So let's go to the code, see what's happening. The first log that you see, log of the spam or not spam, is here. We are calculating it for both classes, for class spam and for the class not spam. And then we need to calculate the rest. So here we have it one placeholder. We just add to it. So here we don't have, so for this sigma, we don't have a new variable. You take this and you just add to it. You just add to it the probability of each word or each characteristic of our sentence, or the characteristic, the probability of each of them in each class, each word in each class. Then you accumulate these logs. At the end, you will have the probability of spam and the probability of not spam. You see which of them is bigger. You report the class. This is argmax. This is the argmax happening here. I will put a comment here and then share this code with you. you have had this code, but now it's mixed with the text. And now we want to test the classifier. Up to now, we were talking about training the classifier. You have a new sentence. You pass it to the predict. It goes to predict. The words come out, and then you go over those words. These words are the characteristics of your subset. And at the end, yeah, this sum is calculated. This sum is calculated, and you see for which class the this sum is bigger. That is your class. So this was the review of naive Bayes classifier.